Alrighty, on page 65, you see an example, not 65, I'm sorry, it was 51? 61, I'm sorry. 61, you'll see an example problem in the textbook, and we're going to work our way through it. And it has two resistors in series, a 50 ohm and a 25 ohm, and it has a total current of 1.4 amps. Now, the problem only asks you to find the voltage total, right? Well, we're also, because this is a voltage divider circuit, we're going to find the voltage drop across each resistor. Now, if you look at your 3x5 card, you have your series rules right in front of you. This is a series problem, right? Everybody agrees to that? Okay. So what we're going to do is, I hope, no, we're going to have a resistor here and a resistor here. Boy, that's a really bad resistor. And a really bad drawing for a battery. Okay, so now we know that this is a 50 ohm resistor right here. And this is a 25 ohm. And what is our total resistance? Our total resistance is 75 ohms. Everybody can see that, right? R1 plus R2, that's our total resistance for the circuit. So our total resistance, so we're going to put down here, I'm not sure how to do this. Okay, where is back to typing? Not sure. Oh dear. Oh, here we go. I think that's it. I want that. No, how do I get rid of that? Auto hide. It says auto hide, but it's not hiding. Oh well. Anyway, I hope I can get back to typing somehow, but I'm not sure how to do that. Well, there we go. So we know that RT is R1 plus R2, and it's 75 ohms. Get back into here. No? Maybe not. All right. So we have an RT is equal to 75 ohms. And then we're going to get rid of this little box. Oh, no. Oh, well. So something I want, by the way, I want to start getting you the habit of doing something. And you see the PEIR right here? Okay. Ooh, that's really bad. Okay, I want you to put that next to every resistor or anything you have. Like your totals, you have R1, you have P1 or PT, ET, IT, and RT. And we have RT already, right? And that's 1.4 amps. And we have our current flow, don't we? I'm sorry, I put our current flow in the wrong place, didn't I? We have 75 ohms total resistance, and we have a 1.4 amp current flow. Now, if you look at your Pioneer wheels, you're going to look over here, and you're going to put your finger over E, because we're looking for E, right? Okay. So if we're looking for E, our formula is going to be I times R, right? So we have our I, which is 1.4 times 75. So we're going to get a voltage of 1.4 times 75. 105 volts. So the first thing we were going to figure out is that we have, let me try this. This is all an experiment. You know that, right? Okay. And then we can get our power by multiplying 1.4 times 105, right? Let's do that now while we're fooling around with it. Oh, I just did the wrong thing. 1.4 times 105. And as somebody said, it's 147 watts, we think. Okay, now, what I want you to observe right now is that we have a current flow that is constant through this whole circuit, right? But what is our current flow? Right, 1.4 amps. Now, if that's true, can we take our PEIR and stick it right here? Which is what we're going to do from now on. Now let's stick in the things we know. We know that resistance of resistor 1 is 50 ohms. Is that correct? Okay. Now, can we stick 105 volts in here? No, because we're going to drop that 105 volts across our two resistors proportionally. What do we know that's always constant? 1.4 amps is going to be constant. So we can multiply our 1.4 times 50. And you're right, we get 70 volts. So our voltage, a drop across resistor 1 is 70 volts. I'm multiplying, just like down here, I'm multiplying R times I. Let me hit pause a second. Oh, wrong button. All right, so we've found the voltage drop across resistor 1. Now let's do the same thing for resistor 2. So now we're going to go to resistor 2, and this time we have 25 ohms of resistance. We still have 1.4 amps of current flow, so we're going to go 1.4 times 25. We find that we have 35 volts. Now, if we multiply 35 times 1.4 amps, we'll find that we have a mere 49 watts. Very good. 49 watts. Okay. So that's a demonstration on how to use your Pioneer wheel. Everybody understand what we just did? Okay, let me stop for a second. Today, not that you want to. All right. So we have 3 resistors, and we need a supply voltage. Somebody give me a voltage. I heard 120. Okay, so we're going to plug in 120 volts. So we're going to get a resistance total, and we have 45, 35, and I've heard that's 80, right? And then 20 more is 100 ohms. That's our resistance total. Quiet on the set. Okay, so now we're looking at our 3x5 card again, and what does our card say? P, E-I, right? Well, we don't need that one right now, do we? We need E-I-R, right? That's the one we need right now. We don't need P-E-I, okay? We need E-I-R because we've got E and we've got so we're looking for I. Well, I don't like that one. Okay, so we're going to look at EIR, and we've got E and we've got R. So we're looking for this one right here, I. Right? Everybody agree with that? So our formula is E divided by R. So our current is 120 divided by 100. I bet I could figure that one out. I bet that's 1.2 amps. And my pen is back off. Let's make it a different color. Now that means that it's, now what do we know about current? Current in series, and this is a series circuit, is constant. So our 1.2 is everywhere across here in our current line. Okay, so now to find our voltage, if we're looking back here and we're looking for our voltage, we just multiply I times R, right? So 20 times 1.2 is what? That's what I've heard. 1.44? Is that right? 20 times 1.2? 24. Sorry about that. I thought. Stop that. Okay, so we can do the same thing, and we can go 1.2 times 35. 42. Now, I want to point out one of the advantages of having the TIX2S instead of the A. And where I have some arrows on my calculator, you can't see them very well, but you see the calculator arrows? I just put in 1.2 times 35. You know what I'm going to do? I'm going to arrow back over the 3 of the 35, and I'm going to put in 45. And then I'm just going to hit enter. Instead of re-entering the whole problem, that just saved me some time, didn't it? So now I know that that's 54 amps, 54 volts, sorry. Okay, and now we can multiply our voltage times our current to find our power. E times I is P, right? So we can multiply. Now I got my 1.2 in here still, so I can just arrow back to the 45 and put in 24. And hit enter, and I get 28.8. Is that the right answer? Wow, how'd that happen? 28.8. Okay. Now, one of the things I forgot to do is when I found my voltages, one of the things I want to do is I want to add those up to see if I've got my total supplied voltage. It's what I call the pure functional magic check. Okay. So I add 54, 42, and 24. Does that up to 120? It's pure functional magic, I tell you. Okay, so it worked. So now we've got 28.8 watts being dissipated across resistor 1. Now let's look at the next one, and I'm just going to arrow back over the 24 and put in 42. And it's 50.4. Okay. And then I'm going to arrow back over the 42, and I'm going to put in 54. And I get 64.8. Now, we want to do our cross check, our pure functional magic check. We're going to add up 64.8 plus 50 point what? 50.4 plus 28.8. And it says we should have over here 144 watts. Now, let's do it with the other numbers, and we're going to multiply 1.2 times 120. And what a shock. Pure functional magic, I tell you, it's 144 watts. So it works. All right? All right, now we're going to stop.